In this video, we're going to talk about angle relationships, and the first one that we're going to talk about is adjacent angles. So in adjacent angles, we had to have some specific things happen. A vertex has to be shared, a ray has to be shared, and there can be no shared interior points. So I have a couple of examples with one diagram to try to illustrate what's going on here. So in the first statement, I have angle AHG, which is AHG, so it's this angle here, is adjacent to GHE. GHE is down here. So the two of these angles combined make this big angle. And so they share vertex H and they share ray HG. And if I want to put a point, say in here, the first angle, will this point be interior to the other angle? And the answer is no, because the entire other angle is down here, so there's no shared points. Let's look at the second example. I have AHE, the big angle, is not adjacent to GHE, the smaller angle. And what is violated in the definition? Well, let's look. Do they share a vertex? They do, H. We also see that in the notation here. The center letter is the vertex. So we see that there is a shared vertex. Do they share a side? A, H, E, G, H, E. They share this ray right here. If I look at this point that I put up here earlier in the interior, it is interior to the first angle here, AHE. Is it also interior to GHE? GHE, it is not. But can we put in another interior point and find that it is shared? So let's try to put a point down here. Is this point interior? It's interior to GHE. Now going back to here, is it interior to AHE? AHE. It is in fact interior, so they have a shared interior point. All it takes is just one, and so it fails the definition for the adjacent angles. Alright, we're going to look at this setup now. And so we have a set of angles here. We have this angle here, and we have this angle here. And together, they form this straight line along the bottom. If we have this, where we have two adjacent angles and the non-shared ray create this line, then we have the linear angle because the two rays combine together to create a straight line. And so linear from your Algebra 1 class talks about something that creates a line. It's the same here in geometry. This is creating a line. Something else about linear angle pairs is that they are also supplementary angle pairs as well, which means the combined angles total to 180 degrees. So if we look at this being angle 1 here, and this being angle 2 here, angle 1 plus angle 2 will equal 180 degrees. And so we call these supplementary angles. And so there's also a theorem that goes with that. So we have a definition and a theorem that surround this idea that this linear angle pair will sum to 180 degrees. An interesting similar condition, when we have two angles that are adjacent angles and the sum of those angles create a 90-degree angle, we call these complementary angles. So we have 180 degrees are supplementary angles, adjacent angles that sum to 90 degrees are going to be complementary angles. When we have two lines that intersect each other, we're going to call these vertical angles. Part of the reason that these are vertical angles could have to do with the fact that these angle measures that are opposite of each other are congruent. Also, the other angle measures here are congruent to each other, but not necessarily to these. And there is a theorem for that the vertical angles theorem, and that theorem tells us specifically this property with the vertical angles, and that's something that you should prove. A special type of vertical angles is our perpendicular angle intersection. A special condition of vertical angles is the intersection of two lines at 90 degrees, and in this case, all of these angles are going to be the same measure. They're all going to be 90 degrees, so this is a special condition of vertical angles.